Hi, today we're going over section 4.1, properties of quadratic functions. A quadratic function has x squared as its highest degree, which means we don't have an exponent that's larger than 2, and takes the form of y equals ax squared plus bx plus c, where a cannot equal 0, and a, b, c are all real numbers. Now, a cannot equal 0 because if a equals 0, that gets rid of our x squared term, and we're left with a linear function. Now, our basic shape of a quadratic is known as a parabola. We will graph our most basic form of a parabola to get the general shape. So we'll do a table values. We'll go from, say, -3 to +3. So -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Now I'll plot these points. So at -3, we are up at +9. -2, we are at 4. -1, we're at 1. 0, we're at 0. 1, we're at 1. 2, we're at 4. 3, we're at 9. So our parabola looks like this. So you can see it varies from a linear function in that it's not straight. And our slope is constantly changing. Now we'll go into some more things about parabolas. So, for example, the vertex is a maximum or minimum value of a parabola. It's where the parabola changes direction. So if I go back to that previous one, my vertex would be right here. Direction of opening, up or down. If our a value is positive, it opens in an upward direction like that last example, so it would open upwards like that. If our a value is negative, so for example, we had -2 in front, it would open downwards like this. Our axis of symmetry is where if you folded the graph in half, the sides would overlap perfectly, and will be an equation that starts with x equals, where that value that goes there would be the x value of our vertex. So if we go back to the previous graph, our axis of symmetry goes right through the center of the graph, right through the vertex. And in this case, our vertex was at 0, 0. So our equation would be x equals 0 for that axis of symmetry. Domain, unless it's a word problem, will be all possible values of x, because we don't really have any restrictions on our x values. Our range, if it opens up, y would be equal or greater than the y value of a vertex. If it opens down, y is equal or less than the y value of a vertex. Okay, so example, find the vertex, the direction of opening, the maximum or minimum, the axis of symmetry, domain, and range. Okay, so first thing we'll do is find the vertex. So this is our vertex here. And we can see the x value of that vertex is at +2. The y value of it is at -2. Direction of opening, our arrows go upwards, so therefore it would be up. Now, the maximum or minimum value comes from our vertex. So in this case, our vertex is the lowest point on our graph, so it's going to be a minimum value. And that value would be the y value of our vertex of -2. Our axis of symmetry, like I mentioned before, is a line that goes through the center of our graph. and has the equation x is equal to the x value of a vertex, so x equals 2. Now our domain, like I mentioned, is x is all real numbers because our parabola is just going to continue forever, both left and right. Our range, we have a low spot here where our minimum is, so our y has to be equal or greater than that location. Next example, graph y equals x squared minus x minus 6 and find our intercepts. So to do this, I will create a table of values. So we have x, we have y is equal to x squared minus x minus 6. So I'll start at -3, go to +3 for now. We may, when we're graphing quadratics, have to choose some other values at times, but we usually start with these values and then assess where it goes from there. So first one, we'll substitute -3 in, so we have -3 squared minus -3 minus 6. So -3 squared is 9. Minus -3 would be adding 3, so 9 plus 3 is 12, minus 6 is 6. Next, we have -2, so we have -2 squared minus -2 minus 6. So -2 squared is 4, minus a negative means we're adding 2, so 4 plus 2 is 6, minus 6 is 0. Next, we have -1. So we have -1 squared minus -1 minus 6. -1 squared is +1. Then once again, we're adding another one because negative of a negative is a positive. So that's 2 minus 6 is -4. Next, we have 0. So we have 0 squared minus 0 minus 6. So that's going to give us -6. Next, we have 1. So we have 1 squared minus 1 minus 6. So 1 squared is 1, minus 1 is 0, minus 6 is -6. Next, we have 2 squared minus 2 minus 6. So 2 squared is 4, minus 2 is 2, minus 6 brings us to -4. Next, we have 3 squared minus 3 minus 6. 3 squared is 9. Minus 3 is 6, minus 6 is 0. So we'll plot these and see where we're at. So at -3, we're at +6. At -2, we're at 0. -1, we're at -4. 0, we're at -6. 1, we're at -6. 2, we're at -4. 3, we're at 0. So our parabola would look something like this. Now looking at our graph, we have x-intercepts here at -2 and here at +3. We have y-intercept at -6. You'll also notice that if our quadratic is in general form, which is what this is, our y-intercept is just this last value here. Okay, so the first difference will tell us if a table of values produces a linear, quadratic, or neither type of function. So what our first difference is we will essentially subtract consecutive terms in our table of values for y, but we have to have our x values equally spaced. So in this case, they're all 1 apart, same with this case, so all 1 apart, so we can do that. So I just take the further down one, subtract further up one, so 4 minus 2 is 2. 6 minus 2 also gives us 2. 8 minus 6 gives us 2. So this one would be linear And that's because our first difference gives us the same number. Okay, we'll do the same thing with this next one. So I have 4 minus 9. That would give me -5. I have 1 minus 4, which gives me -3. 0 minus 1 gives me -1. So you can see in this case, they are not all the same. However, because they changed by the same amount, because each of these is 2 apart, that means it's going to be quadratic. So once again, it's quadratic because our first difference is we're changing by the same amount. Okay, so practice for this section is on page 277.